Today, we'll be learning about the topic of echoes. So to start with, I want you to think about all the times that you've heard echoes. What did the locations have in common? Were they indoors? Were they outdoors? Was there much space? Was there clutter around material? Think about why you hear more of an echo in a room with no furniture or curtains, and less of one when there is furniture or curtains. Here are some keywords for you to remember during this lesson. I suggest you pause the video here for a moment and copy these down, as they will help you throughout the lesson when I go into some more detail. So we start off with the obvious word, echo, said echo, which is the reflection of sound from a hard surface. Then we have ultrasound, pronounced ultrasound, and that is sound with a frequency higher than the normal hearing range of humans. Finally, we have sonar, the use of sound waves to communicate with objects underwater. So, our learning objective is to explain why a submarine uses sonar to detect other submarines. In order to do this, we need to be able to describe the reflection of sound and calculate the speed of sound waves. Now, for the IAG, we have that boats use echoes to help them navigate in the form of foghorns and sonar. Captains of commercial cruise ships and liners can earn to a massive £100,000 a year. Now, I used to work in the sonar industry, and I can tell you how sensitive they are. From a dockyard in Southampton, we can hear boats moving around in the docks all the way over in New York in America. So, what are echoes? I want you to write down your own definition. Look at the diagram below. Think about what part the wall is playing in all of this. What is happening to the sound waves coming from the buoy? Use a green pen to mark yourself and take a photo of your work to upload to class charts. This sentence coming up might help. So, a sound or sounds caused by the something of sound waves from a surface back to the listener. Now, our secure question is, what affects the pitch and volume of a sound? Think back to the lesson that we had previously on sound. Pitch affects the frequency, and the amplitude of the wave affects the volume. Thinking about what you've just learnt about echoes from the previous slide, pause the video here and unscramble the words below. Then use a green pen to mark yourself and take a picture of your work and upload it to class charts. So, after that, think about how ultrasound works to detect babies. Here we have the answers. An echo is a reflection of sound waves from a hard surface. Echoes are used in ultrasound to detect unborn babies. Bats use echolocation to locate their prey. Submarines use echolocation in the form of sonar to determine the location of other submarines and oil spills in the ocean. Now, how do we detect babies? Well, this machine here, this ultrasound emitter, which is attached to an analyzer there in the laboratory, it sends pulses of ultrasound through a gel on the mummy's tummy through her skin. This then reaches the baby and is reflected back the way it came to the receiver. This then comes up on a screen and we can see how baby is doing. So, how can ships use echoes to determine the depth? Well, we can use the speed equals distance over time equation, which you can see on the right, to calculate this. So, if we know that the speed of sound in water is 1,500 meters per second, and it takes 3 seconds for the sound to echo back to the ship, then the distance covered by the sound can be calculated using 1,500, which is the speed, times the time it took, which is 3 seconds, which gives us 4,500 meters. Now, if the sound travels a total distance of 4,500 meters, then we can use what we know about echoes to work out the distance to the seabed. So remember, echoes travel to an object and back. So the distance to the sea floor is 4,500 meters, which is the total distance the waves come, divided by 2, which is 2,250 meters. Remember, the waves have to travel from the boat to the bottom of the sea and then back again. This is why we divide the distance by 2. As a quick reminder of how to use formula triangles, have a look at the example here. So, cover the section that you are looking for with your finger and then follow the instructions of the triangle. In this example, we want to find the concentration. So we would cover concentration with our finger and then figure out that it is moles divided by volume, which can be seen in the example there. Here are a series of questions on Sonar for you to try. Pause here and have a go yourself, and then we'll both go through these together. Number 1. To start us off, we have the equation v equals 2s over t, where v equals velocity, or the speed. S is the distance, so in this case, the distance from the boat to the seafloor. And then t, we have time. So in this case, v equals 1,500 meters per second, because that is the speed of sound. T is 5 seconds, and S is what we need to find. So we rearrange to get distance or displacement on the left side. So we have 2s, remember, because the sound needs to travel from the boat to the seafloor and then back again. So it is essentially doing double the distance. So we plug in the numbers. 2s equals the speed of sound in water, which is 1,500 meters times 5 seconds, gives us 2s equals 7,500. We then rearrange, bring in the 2 there to divide the 7,500 by 2, giving us 3,750 meters. Now for the second question, we have a similar process where we want to get distance on the left side, so we rearrange, we plug in the numbers, so we have the speed of sound there being 340 and the time being half a second. We times those together, giving us 170. Bring the 2 over, 170 divided by 2 is 85 meters. Pat yourself on the back if you got both of those right. Now, what things stop echoes? We've already asked the question a few times about what the circumstances were where you could hear echoes very well. Now, let's think. What would a blanket do to sound waves and why? What do you think ceramic tiles would do to sound waves and why? And what do you think water would do to the sound waves? Now I want you to pause it here and have a go at writing this yourself, and then mark it against the answers coming up in a second with a green pen, and then take a picture and upload it to class chats. So, blankets absorb the sound waves. Now, why is this? Because it acts as another blocker, something to absorb vibration and energy in the vibrations, meaning that the sounds will have a lower amplitude. Ceramic tails are much harder than towels, and hard surfaces are good at reflecting waves and therefore will reflect the sound wave, causing an echo. In water, sound travels much slower than in air, but remember that in swimming pools, they do have the ceramic tiles, which we mentioned earlier. So once the sound has traveled through the water, it can still be reflected off hard surfaces. Now, soundproofing is all about reducing unwanted sounds. So here we say, when recording sound in recording studios, there has to be no surrounding noise, which is why when you're listening to music, you can't hear random conversations or people making cups of tea in the background. It's because they likely have very effective soundproofing. Now, from these images below, which do you think is the most effective or would be the best choice for using soundproofing? Now remember, what issues are there that you can see with each of these? None of them are perfect and they all have their positives and negatives. We can see from the foam that while it's 20 meters per square meter, it's not biodegradable, which means that it won't decay if it gets thrown out. Cork, on the other hand, is much cheaper at £5 a square meter. It's also biodegradable, although it is produced by deforestation, which is cutting down trees. Wool, on the other hand, is the most expensive. It is biodegradable and it comes off of sheep. But that price might be a potential blocker to some people who may not be able to afford these. So just something to bear in mind.